divide it further down the line. So this has to be changed altogether. Okay. Apart from that, attribute domains may also include a null value. So I'm sure all of you are familiar with the null value. So in DBMS systems, it is a bit different compared to your programming language null values. So in C++ or what have you, you have your null values, your nil values, or what have you, your null pointers, and those are usually a sets of zeros assigned somewhere. In DBMS systems, a null value is essentially a value that is unknown or unspecified. That means that I cannot compare two null values. I cannot say that if this is equal to null and this is equal to null as well, or both of these are null. I cannot say that, right? I cannot compare if two of those are null. Those cannot be compared. Null values can often complicate matters for the most part. So generally, it is a good practice to avoid null values as much as possible when we are designing our models. Okay. Now, what is a relation variable and what is a relation value? So more formally speaking, and I know I'm being pedantic a bit, but essentially we need to get these terms right. A relational variable is essentially an instance of a schema, right? So in this particular case, account would be a relation variable that explains that this name is associated with a specific schema and it has a set of tuples that satisfy that particular schema. So that schema is, it has three attributes: account ID, branch name, and balance, right? So this account is a relation variable that is from a particular schema, and all of its tuples satisfy that particular schema. Usually, sometimes a relation variable is abbreviated to relvar. But yes, you can, sometimes I might talk about relvars. That is what I mean. Now, another thing that we need to know is what is a relation value. So a specific set of tuples in my table in the same schema. So in this particular table that has the same schema, I would, if I have a subset of tuples selected or the entire table, but essentially a specific set of tuples, maybe the result of some query that we are doing, or maybe the result of modifying that particular table, we would call that set of tuples as the relation value, or sometimes abbreviated as relval. Okay. This becomes slightly irritating because formally this can also be called a relation. So up to now we were calling account a relation, and that is what it is. This is a relation. That means that it is a set of tuples from a particular relation that contains a particular relation set of tuples. That means that it is a relation value, which is a member of this relation variable, which means that essentially that follows a particular schema. Okay. Basically, it can be associated with the relation variable. Now, the problem comes when some books and some people start calling both a relation variable and a relation value by the same name, as in a relation. So in general, when we say a relation, usually we mean the collection of tuples, right? So the collection of rows that we have, basically the relation value. However, less formally, sometimes people also mention a relation variable, which is basically an instance of the schema. People also call that a relation as well. So the account relation is basically going to be a relation variable that holds a particular relation value. Okay, moving on. So we talked about tables and what they look like, and we talked about relation tuples, relation variables, relation values, schemas, and things like that. Now, the next thing that we are going to talk about is how can we distinguish different tuples. We know that a relation is a set of tuples, right? And we know that these are sets. So that means that no two tuples can have the same set of attributes. However, to be more exact, we need to say that no two tuples can have the same values for all attributes. Whereas some tuples can have same values for some of those attributes. So for example, in this particular relation, we can see that the attribute branch name has two Los Angeles names in its tuples, right? So this does not mean that this is not a set, or for the attribute balance, we have $275 as balance. This does not mean that this is not a set. That just means that essentially some attributes can have duplicate values, but some attributes need to have unique values to differentiate among them, right? Okay, so if we are saying that in that scenario, if we have multiple possibilities where attributes can have duplicate values, we need to have some attribute, mainly in this case the account ID, to still be able to differentiate between different tuples. So already we are distinguishing between different types of attributes, right? There are some attributes that can have duplicate values, some attributes that cannot have duplicate values, right? So that is the main thing that we are going to talk about when we are talking about keys. So keys are essentially attributes that allow us to distinguish between different tuples. A key basically, or a super key, is a set of attributes that will uniquely identify your entire tuple, right? So it can be one attribute, it can be two attributes, or in this particular table scenario, it can be all three attributes. So if I say that account ID, branch name, and balance all together would make a super key, am I correct or am I wrong? So using these three attributes, can I say that I can identify every tuple uniquely? Account ID, branch name, and balance.
Yes.
Yes? Anybody else who thinks no? Do you want me to ask the question again?
Wait. Um. Maybe no.
No? Okay, so we have
No.
one who has reverted back to a no. Any other
I think
answers?
yes.
You think yes? Okay.
Yeah.
Anybody else?
Uh,
Type in
can
the
we can you
uh,
repeat the question?
okay. Type in the chat window whether yes or no. I will repeat the question. So a super key is essentially a set of attributes. So it can be one attribute, two, or all three of them. So a set of attributes that needs to uniquely identify tuples in my entire table. So if I say that this is my super key, that means that this super key will only be possible in my entire table only once. It cannot, that super key cannot be a duplicate. Okay. So in that sense, can I have account ID, the combination of account ID, branch name, and balance all smooshed together? Can we say that these three things together make up a super key? So can we use these three attributes to uniquely identify every relation in my database?
Yeah.
Yeah, right? Anybody thinks no? Raise your hands. Yes, okay. Let's just quickly check if anybody else is raising their hands. No. Okay, so if I have account ID, branch name, and balance, I can have two accounts with the same balance. I can have two branches with the same name, but I cannot have two account IDs that are the same account IDs, right? So if I bring them all together, the account ID is still going to be a distinguishing feature. If I bring these all of these three things together, so that means there cannot be another tuple with the same record such as A307 Seattle 275. These three things together cannot occur again in my table. Otherwise, it will dispute the set condition, right? Okay. So, yes, so all of these three things together do make up a super key. But as Angelina pointed out, and as Angelina as I was talking about it, we can see that not all attributes are really important, right? So if we remove the balance attribute and we just have account ID and balance, this is still a super key, right? Because I can still distinguish between all my tuples with just those two things, right? If I also remove the branch name from this, account ID itself is still a super key, right? So if we remove all of the extraneous attributes that are not required to be to make sure that this particular set of attributes are super keys, then that is what we call as a candidate key or a minimal super key. We will come to that in a second. But a super key is essentially the set of attributes that can be used to uniquely identify tuples. So account ID and balance can be used as a super key. However, branch name cannot be used as a super key because there are duplicates of branch names across my table. We have Los Angeles, we have Los Angeles, we have New York, we have New York. So there are duplicates of branch names and that cannot be used as a super key. So at least branch name on its own cannot be used as a key. Okay.
I have a question.
Yes.
So account ID, branch name, and balance can be a super key. Okay.
Yes.
And,
Because it is still useful for distinguishing across your tuples.
okay.
Right?
And but the more efficient key is the account ID because there is no duplicates of account ID.
Yes, and we call those efficient keys as candidate keys or primary keys. Super keys are essentially the entire umbrella of terms that can be used as keys.
Okay.
Right? Okay. So, as we said, as she said, a minimal super key is essentially going to be the set of keys that are important in order to identify those individual tuples. So they are not duplicate in their own terms, right? So we call those keys as candidate keys. So account ID is a super key, but so is account ID and balance. That is also a super key. But only account ID would be a candidate key because it has no other flurry extra attributes, and without those we can still make it a key. So is it safe to say that every superset of a super key is a super key? Yes. That is a very important point, Caleb. And on that note, yes, adding more attributes to a super key would produce another super key because it already contains, it has to contain a set of attributes that has the basic requirements to be a candidate key. That is the basic requirement, right? So super key, and then we have the candidate key. Very good question. Okay. Now we come to primary keys. So primary keys, so a relation can have multiple different candidate keys. So for example, in this table, we can have a customer table that has the customer ID, the customer name, and customer social security number or your taxpayer ID number, what have you. So in this scenario, customer social security number can on its own be a candidate key. On its own, the customer ID can also be a candidate key. So there are multiple candidate keys for a particular relation. We need to pick one of these possible keys for our databases. We call that key, that is a member of those candidate keys, as a primary key, right? So a primary key will uniquely identify tuples and it is one of the candidate keys. Now, in this scenario, as I said, either customer ID can be a candidate key or a primary key, or customer social security number can be a primary key. However, and this is something we will talk about later down the class, however, we will choose customer ID to be our primary key instead of customer social security number. There are certain